Good afternoon, everyone, and welcome to the CodyColorKIT launch event. We are thrilled to be here today with you and to start exploring together a new Code Week training resource specific for teachers and the educators. I'm Veronica Ruberti, and I am the coordinator of the Italian New Code Week National Hub, and so the coordinator with the leading teacher and the Italian community. And I'm not alone here today, and I'm here with Alessandro Bogliolo, that you might know well known. He is the Italian New Code Week ambassador and professor at University of Urbino, plus the scientific author of the training resource that we will explore together today. Welcome, Alessandro Bogliolo.
Thank you, Veronica. Good afternoon, and good afternoon, everybody.
Great. And so today we will be here together 1 hour, and we are excited to start exploring this new training resource. And I would like to start presenting this new resource with a story, to be honest. And so today's event will start with once upon a time, because once upon a time there was a main character who is the second speaker today, who is Alessandro Bogliolo, as I said, professor at University of Urbino, who developed unplugged method to foster computational thinking skills since early age at the primary school level. So this unplugged method is the so-called CodyColor method, which has a peculiar aspect, which is super, let's say, cross-age and cross-disciplinary, because really young students and really young people have the same challenge of adults when try to explore the CodyColor method and try to develop their computational thinking mindset. And the approach and the method of the CodyColor method was so strong that was adopted by a really passionate group of leading teachers. The Italian leading teacher, you can see the picture here, who adopt the method, test the method in the year. We are talking about a story which started more than 10 years ago. So it's a mature and well-established story. And so really motivated group of teachers and leading teachers in Italy adopt this method, try and experiment with this method into the classroom settings. But to be honest, not only in the classroom settings, but also in the town squares, because there were many festivals around Italy in which the CodyColor method was used to engage also adults as a playful game, and they weren't aware that while they were having fun during a festival or a festive moments in the town, they were training their computational thinking thoughts and mindset. So this movement, the Italian New Code Week movement, has this strong DNA around an unplugged method that is really inclusive, because it doesn't require any device, any equipment. And to be honest, it has also a really low language barrier, because it's based on color codes. And we will start exploring that. So the next phase of the story that I'm telling to you is that, next slide, please. Okay. Two leading teachers from Italy, Fabrizia Agnello and Melina Kundari, brought a CodyColor activity in the last European Code Week meeting that we had the last September in Madrid. As you can see in this last picture, many leading teachers, many members of the EU Code Week community tried and had fun with the CodyColor activity. And so that moment somehow brought us to today's meeting, to today teacher training resource that we will present. Because in that moment, as an Italian community, we realized that we wanted to make CodyColor method and instruction and activities templates available for the whole European Code Week community. So let's say that somehow I like to describe this resource as a gift from the Italian community to the European New Code Week community to keep on to having an extra resource as a common ground to keep on collaborating and learning together and coding together. So yes, those three faces are the three Italian leading teachers who took part with us, with me and Alessandro Bogliolo, in the co-design phase of the training resource that you will explore today in this launch event. So I really would like to thank Fabrizio Agnello, Melina Kundari, and Alfonsina Cinzia-Troisi, because they were there in every session in which we design the kit and the landing page, and maybe you might have seen their faces on social network, because we rely on their motivation in order to share their voice during the social media campaign for today's launch event. So I really would like to thank them. And this is the story, the behind story of the CodyColorKIT that we will start explore super soon. So we will go to the next slide with today's agenda. Yes, we can go on to the next slide. So today we will explore some methodological aspects together with Alessandro Bogliolo, and we will go through the resource together in order to understand how it's structured and how you can use it to learn the method and then to start to apply the method into the classroom setting. And we will conclude with some following and next steps. And for this reason, I will suggest you to sign the attendance form. So go through the QR code that you can see on the top right corner here, or go through the link that they will share in chat, because in such a way we will send you the slides, the materials, and also follow-up information regarding the resource that we will present to you today, and we are starting really soon. Alessandro, it's your time.
Okay, thank you very much for this presentation, this introduction. I think that what we will do right now is, first of all, go through the methodological aspects of CodyColor and then explore the resource. But while going through the methodological aspects, we will take a very practical approach, hands-on approach, and I take advantage of having Veronica here with me in order to demonstrate how to play with CodyColor, because CodyColor is a method which is general enough to be used as any coding instrument to develop many different activities and games. And in the kit, we decided as a starting kit, as a starter kit, to suggest just one activity, which is very engaging and very general, because this could be used at any age, basically, thanks to the very simple elements that compose the CodyColor method, but on the other hand, to the challenging activities that can be built on top of it. So let's start with the methodological aspects. Okay, so I need to mention that the CodyColor method was developed several years ago. as Veronica mentioned, and this was developed by myself primarily, but also with the help of many teachers during a summer school here at the University of Urbino. And based on this method and other unplugged coding activities like CodyColor and CodyFit, a CodyRobi Academy was founded in order to provide guidance on the proper use of this method and on the way of using unplugged coding activities in order to develop computational thinking skills and to bring coding into the classrooms. Unplugged coding activities have the key advantage of having no prerequisite, because you don't need any technical equipment in order to be able to practice coding. And what you need is nothing but a floor where to play, so a floor to be used as a playground, as we will see in a moment. Okay, let's start with Robbie. Robbie is a robot, because what's essential in coding activities, any coding activity, not only unplugged, is the relationship between a programmer and an executor, a performer. So the programmer writes the code, and then the performer, the executor, executes the code. This means that this relationship, which is kind of delegation of the execution, basically needs a code to be formally defined and a language to be used by the programmer, the coder, in order to provide instructions to write a program to be executed by the executor. And this is very important, because only by developing a program that is clear enough and well formed, then the programmer, the coder, can ask the performer to execute the task, taking all the responsibility of the result of the execution. Because without a formal language, which is a shared agreement between the programmer and the performer, the programmer couldn't take the full responsibility of the execution, while in this case it does. Okay, so Robbie is a robot, and what's essential in this robot, which is seen from above, is that it will represent a piece in our game, in our board game, that will just represent what I encourage you to do in practice on the floor. And instead of having a robot or a piece to be moved on a board, I suggest having one of the members of your team to play the role of the ideal executor, directly stepping into the board, into the playground, into the grid that will be then prepared on the floor. But what's essential of this piece, of any kind of piece that will represent a robot and the executor in this activity, is that we clearly see the direction. And the direction in this case, you see, is clearly represented by the eyes, which are these ones, by the hands and by the feet. And looking at these elements, we clearly understand that in this case, the robot is facing north, which is the top of the screen. This is essential because if we want to provide an instruction that corresponds to an action to the robot, we need to know in which direction the robot will move. So any instructions that we provide to the executor has to be interpreted and executed from the robot's perspective. Okay, now let's move to the colors, because the method is called CodyColor because instructions are directly encoded by colors. We will have three very simple and different colors, gray, which is this one, then yellow and red. And what's peculiar in CodyColor is that the colors are not providing a different space to write a program somewhere else, but they are directly placed on the playground, directly placed on the floor. So this means that the robot reads the instruction, interprets the instruction, and then executes it only by stepping into the tile that represents the instruction through the color. So in this case, the robot is facing a gray tile. When the robot steps onto the tile, then at this point, the robot interprets the tile, and since the tile is gray, gray represents in CodyColor go straight. So this means that in order to execute it, the robot does not change the direction and then steps to the next tile in order to look for a new instruction. This is another key point. Any computer, in order to execute a program, to execute a code segment, reads instructions one after the other. So takes the instructions as a sequence. And this means that whatever the code tells the robot to do, the robot is doing two different tasks together. On one hand, the robot is moving along the code, along the program, in order to read an instruction after the other. And on the other hand, the robot is also moving on the playground, on the action plane, where the instruction corresponds to specific actions, to very elementary actions that are associated with the instructions. Okay. This kind of separation between the code and the space where the action takes place is something that can be considered to be very abstract at very early ages for preschool kids and for the first year of primary school. And that's why this method was developed in order to allow the instructions not only to be represented as colors, which means that they do not require any reading capability, for instance, but also to be placed directly along the path. So this means that the abstraction is reduced on one hand, but then there is still the agreement, which is somewhat abstract, because we need to remind that gray means go straight. Okay. Then there are yellow tiles, and whenever the robot steps onto a yellow tile, then the robot interprets it as turn left, and this means that to execute the instruction, the robot has to turn left, which means turning 90 degrees to the left, and then it will go to the next tile to see if there are further instructions to be executed. What about the red tile? I think you can guess that red tiles mean turn right. So this means that at this point, the robot turns right before moving forward to look for further instructions. Okay, so those three instructions build what we could call an instruction set. Instruction set is a technical term, which means all the instructions that are available in order to write a program. So whatever programming language you choose, there is always an instruction set. So specific keywords that correspond to specific actions that the performer will execute. And just leveraging on this instruction set, you have to write the code in order to accomplish a complex task. In this case, we have to compose these tiles to build a path. And this is a very simple example, which I call a good example. Because if we compose the tiles in this way, what happens is that when we, I would say start to the robot, exactly as when you launch the execution of a program in your computer or on your smartphone, what happens is that you tell the computer, which is the executor, the performer, okay, now execute the code. And then the computer or the smartphone starts reading the lines of code one at a time and each line of code will be read, interpreted, and then executed before moving to the next one. In this case, in order to start reading the code, what the robot has to do is to step onto the path, so to enter onto the tile in front of him. And this is what happens. So since the tile is red, it is interpreted as the first instruction, and since it means to turn right, then the robot turns right. And then the robot moves to the next tile exactly as any computer will read the next instruction on the program. So this is the next tile, which is a yellow. Yellow means turn left, and then the robot turns before moving to the next one, which is gray. And at this point, while moving to the next tile, the robot doesn't find any new instruction, and this means that the program has finished. And so the execution is terminated. But using the same tiles, we could also make a bad example, which means doing what we could call a programming error or a bug. Because if we want to make the robot follow this path and we use the colors in this way, even if we can see kind of a path, because it's quite easy here to follow this path, if we tell the robot to start the execution, then we will soon see that by turning right and then going straight, then the robot will fail in completing the path just because we put the wrong colors. So this means that CodyColor allows us to make errors. And this is very important because any programming language should basically allow the programmer to make errors, because otherwise there would be no freedom and also no learning experience if we were not able to do something wrong and then understand what was wrong and do what is called debugging. Okay, I'd like also to show you an example of a non-trivial path, in the sense that we can keep adding tiles and we can also make our floor full of tiles, of colored tiles. And while before we had just a very simple straight path, in this case we have still a path, and I'm just curious to know if you can see the path following the colors, but the path is this one. So since I have no means for asking you to tell me which is the path that you have seen in this colored square, I just point out which is the path that the robot will follow by following the colors represented by the tiles. Okay. Now it's time to introduce the chessboard, the grid, which will be our playground or our learning space. So as I mentioned, I suggested this 5x5 grid to be built on the floor. And this can be done in many different ways, like, for instance, using the tiles if you have a floor with square tiles, or you can use any other way of just marking the borders of these squares. But in any case, we also need to use row and column labels. I call column labels the letters because I see columns in this way, and row labels the numbers because I see horizontal lines in this way. But then I also add directions, which are, as you can see, north, east, south, and west, because south is south, sorry, there is an Italian version here. I should change it in too many slides, so I will I will leave sud instead of south, but I'm pretty sure that there is no misleading, because this is not misleading because of the other directions that are properly written. Okay. Now, the other elements that we need are the pieces that will be placed to this board in order to represent the position of the executor. And then we also need the tiles, the colored tiles that represent our instruction set. And now we are ready to start. To start doing what? So, for instance, we could conceive a cooperative activity, and now I can ask Veronica to try to play with me just to see how a cooperative path can be built. So basically what we could do, Veronica, is to add a tile at a time. And I ask you to choose the tile to be placed in front of our robot. And then based on the tile that you choose, I will add it to the board and then add another tile in my turn. Okay? So first of all, I ask you in the coordinates of the square in which your tile has to be added, just to make sure that we are on the same page, let's say.
So you are so you are asking myself which is the next coordinate, right?
Yeah, the coordinates. Yeah, which are the coordinates of the
Okay,
next?
got it. I got
The
it.
next? No. Which are the coordinates of the square where you will
Position.
place the next tile?
Okay, got it. So it's gonna be before. B
Okay,
as
very good.
breakfast. Okay.
Perfect. And now you can tell me which color you would like to add in this place.
Okay, just let me know which is our goal, to stay in the
Our
grid
goal
as
is
much as we can.
just to build the path, and then let the robot follow the path.
Okay, I will say that I will use the yellow tile.
Okay, so let me add the yellow tile for you. Here it is. Now what happens is that I'm not moving the robot. I could move the robot. So let's assume that I move the robot now. And imagine that instead of being on a screen like now we are all around a chessboard built on the floor, and that there is a boy or a girl playing the role of the robot. And as soon as we place a yellow tile in front of her or him, what happens is that the person in charge of playing the role of the ideal performer steps onto the tile and then executes what the instruction represents. Okay? So right now is my turn, and I can choose which color to put in front of the robot, which means in position A4. And I have not declared a common goal. The common goal could be building the longest possible path. So assume that this is our goal. If, for instance, here I put a gray tile, then I will fail, because with a gray tile, the robot will exit from, and then this means that this path will be very, very short. The most reasonable choice could be a red at this point, because with a red, I move the robot toward the, basically the direction in which there are the majority of the empty tiles. But instead of doing so, I put here a yellow tile again, and I ask Veronica to make a choice. based on the fact that I selected the yellow for this tile. And what I could do now is let the robot move and execute the instruction. So Veronica, what's your choice?
Yes, just
in
let
A5.
me, and I'm embodying and demonstrating that there is a lot of geospatial orientation in this activity. So my choice is to add another yellow tile.
Okay, that's a very good choice, because this is actually the only one that keeps the robot still within the board. Because right now, if we simulate the movement of the robot, what happens is that the robot moves here, but then the robot finds a new tile to be executed, even if Veronica added just one tile. But since the robot moves to a new tile whenever there is a new tile in front, then it also executes this further movement, which is a gray tile representing ghost rates. Ghost rates means that the robot is not to turn left or right, but just to wait for the next tile to be placed in front. And what happens here is that I could, for instance, add a gray tile, and here is the gray tile. The robot moves to the gray tile, and it's again Veronica's turn.
And I will include another yellow tile.
Okay. So let me just place a red tile somewhere, because otherwise we miss a color. So I choose a red tile right now, and so on. But now I ask Veronica to add another one.
Yeah.
Okay.
So let's say that I will put gray.
Oh, that's terrible.
Terrible.
Okay. Yeah, because with a gray tile, the robot goes straight, and the path finishes outside the board. And this means that as a result of our execution and our cooperative work, we were able to build a path, the length of which can be measured in the number of steps that the robot made before exiting from the board. Okay? I'd like to point out that the difficulty of this task can be increased just by leaving the robot at the starting point until we finish building the path. So assume that we have not made the robot move during programming, during the phase in which we were cooperatively building the path. Then it would have been much more difficult for us to figure out where the robot was, and which was the place in which the next tile had to be placed. Okay, so I pointed this out in order to let you figure out which is the kind of gameplay which is more suitable for your kids, depending on their age and also on how familiar they are with this kind of activities. And difficulty can also improve over time. Okay, this was just to present the method. This was not the activity that we want to propose today. And so let me move to the next part where we present pas de deux. Pas de deux is the competitive activity. And once again, I need Veronica to play with me in order to demonstrate how this activity works. And
I'm a bit stressed, to be honest. And I'm sharing a call to action to anyone who is participating in this live event to support me by sending me instructions on how to survive this battle.
Okay, and by the way, you can provide your hints or suggestions in chat because we can see the chat, and Veronica can take advantage of it, and myself I can take advantage
Please.
of your suggestions, because there is something else about coding that I would like to point out, that coding and programming is an error-prone process. And that's what is very nice, because errors in coding, in programming, are part of the process. It is almost impossible to write code without adding errors, mistakes, or bugs within the code that we write. So it's very, very important in order to be able to write good code, not to pretend to write code correct by construction, but to have sufficient skills to find the errors and to correct them. Okay, now this is a competitive activity, and we have two robots. The robots start from the positions that you see, and from gray tiles. And Veronica play with the white robot. I play with the pink one. And I ask Veronica to make the first move. So Veronica knows what's the main purpose of the game, but while she is figuring out which color to put in front of her robot, I tell you what's the goal. So the goal is to build a path for a robot which is longer than the path that the other team is building for the other one. Okay. And what is nice of this kind of activity is that the chessboard is the same. So this means that the tiles that each team is placing for her own robot will also affect, sooner or later, the behavior of the other one. Let's see what will happen. Veronica.
Great.
Okay. Okay, in this case, I moved the robot, but try to figure out what will happen if the robot remained in the starting position. I make a different choice for my robot, and I choose a yellow tile. So this means that my robot will move to the tile and then turn left. Your turn.
Yes, yellow.
Okay. Here you are. I choose a gray tile.
Okay, and now it's my turn, and I choose yellow again.
You don't want to meet?
No, I'm scared.
Okay. So I tried to chase you.
Uh-oh. Gray.
Okay. Okay, let me see what I can do now. Okay, I take a gray because otherwise I will. Okay, your turn.
Okay, so
I think you have no choice.
yes, let me turn myself, and so I will use, of course, red.
Okay.
My survival choice, red.
Okay. Good move. Okay, now I have to be very careful, because if I go left, then I will exit. If I go straight, I will finish in your hands, because this means that if I, with the gray, I will come here facing south. And this means that my next move will be decided by you. And so that's why I choose red in my turn, in order to avoid this situation in which you will for sure make a choice which will put me out of the board.
Okay. So same story for me.
Mm-hmm. Yeah.
Because if I use red tile, that will
Mm-hmm.
mean that I will go next to another red tile that will bring myself, I mean my
Yeah.
robot, straight to outside the grid. So game over
Yes.
for me.
Yeah.
And I don't want to lose. I'm really
Yeah.
competitive tonight, today, and so
Okay.
I will use gray.
Okay. Okay. I don't know. Well, I choose a gray in order to allow you to do a different move if you want. And I recommend you to do so.
Yeah, so in this case, I will use a red tile.
Very good choice. You are much stronger than I hoped. Okay.
That's because I studied the CodyColorKIT before the webinar. That's why.
Okay. Okay. Now, this is the first situation in which something weird is happening, because this gray tile was already there when Veronica made her choice, and this means that the position of her robot is this one, in the sense that in this kind of activity, which is once again called pas de deux, each robot moves as long as there are colored tiles that represent instructions, regardless of the fact that the tiles have been placed on the board by the robot's team or by the other one. So in this case, the gray tail was placed by myself, but Veronica's robot is taking advantage of it. So this means that, Veronica, the place where you have to place your next tile is this one. So B3.
Yes. So let me see. Duck. I would go with red. Yes, with red.
I'm not happy with your choice. Okay, so red means that after having executed this instruction, the robot finds in front of it another tile which is gray, then goes straight to the next one, which is yellow, and then at this point, this is the result of the execution, And here the robot waits for the next move because there is an empty tile. Now it's my turn. And as you can see, my turn is very complicated because at this point, I have basically no choice, because if I move left, I will finish outside. If I go straight, I will finish outside in 2 steps. So I have to choose red. And with red, let's see what happens. I move here. Turn right. There is another red, so I turn right again. Then gray, which means go straight. Then red, which means turn right. And I stop here waiting for the next move. Your turn, Veronica.
Okay, so uh, hmm.
Any suggestion?
Any suggestion? Let me see the chat. No, not so far. So in this case, I will add a gray tile.
Okay. And my only choice is red again. And let's see what happens with this red here. So I turn right. I turn right again. I go straight. Then I turn right. Then here I go straight. And what happens is that now I'm outside the board. Yeah, so this means that I finished my path. But it's your turn now, because this game doesn't finish when one of the 2 robots finishes outside the board, because the main purpose is to build a path which is longer than the path of the other robot. So even if I am outside the board, you still need to play in order to make your path longer than it is right now. Because once your robot finishes outside the board, we will compute the length of the 2 paths and decide who is the winner. So, your turn. I suggest you to move fast here, just because the lack of time and because I don't want to lose.
Okay. So I will use a yellow card.
I'm afraid it's a good choice. Okay.
A gray card.
Okay, here it is.
And a yellow card.
Very nice. So the gray, I put also the yellow, and then I execute both of them. So go straight, turn left. Here it is. Go straight, turn right, turn right, turn left, and that's it. Now, what's the longest path? It is not so easy to evaluate, and in order to evaluate it in a very funny way, what we recommend is to place the 2 robots, the two robots back at their starting points, and then make the two move together by clapping hands. So imagine that there is basically all your classroom playing this game, and the two players, actually the two pieces, and the two boys and girls who are pretending to be the robots are on the board, while the two teams are around the chessboard on the floor, and they start clapping hands. Every time the teams clap their hands, the two robots move a step. So this means that both robots move to the tiles in front of them and execute the corresponding instruction. The other people wait for them to finish their moves, and then they clap their hands again. And then there is another turn, another move, another turn, another move. At some point, one of the two robots will end up outside the board, while the other one will still be inside the board. And this means that the number of hand claps that each robot can afford staying on the board is the score of the team. And this means that at the end of this match, the robot, or better, the team, the robot of which will move for a longer number of claps will have the highest score. And what we recommend is that you make 3 matches by summing up the scores of all the 3 matches in order to determine the winner of the overall game. Okay, this is the game that we suggest. But now, since we are running out of time, I want to, first of all, let me thank Veronica for this demonstration, but I want to let Veronica introduce the kit. So, Veronica.
Great, thank you. It was stressing, but also I had fun. So I think it's an activity that take all your thoughts in your mind. You don't have time and cognitive effort to think about something else. You just have to think about the color tiles. So
that's a good point.
I think I think it's a good strategy also to refresh when we are thinking on the same things over and over. Okay, but let's go to the training resource. So basically, thanks to Alessandro Bogliolo, we just had a nutshell of the methodological aspects that are described in the CodyColorKIT. And the CodyColorKIT is publicly available on a specific webpage on the Code Week website. And we will share the link to this webpage in chat and in the following up emails. And so basically, when we click on and we land to this the CodyColorKIT page, we will find, next slide.
Here it is. Should I move next?
Yes, I'm sorry. Yes. We will find an infographic that represents the learning path that we suggest to you teachers, educators. So first of all, it's to discover the method, and to understand and to understand how to prepare the learning space into the classroom when you want to lead and facilitate a CodyColorKIT activity. And then there is the third section, which is discover the lesson plan. So it is the description step by step of what you as an educator, as a teacher, you should do in order to guide your students to experiment a CodyColorKIT activity.
Okay, I did something magic, which is
Wow.
making the kit appear here. So I can scroll it now to let you see
Exactly.
what we are mentioning. Okay,
Great.
but I have also to move the slides because Veronica was mentioning. Okay, so this is the CodyColorKIT. So discover the method. And the methodological part explains what I explained in the video in the first part of this webinar. Here it is. So you see how to build the chessboard, how to place the robot, the coordinates, the colors, the meaning of the colors, and so on. Okay, then Veronica.
Exactly. When you learned the basic things about the methods, you are ready to start preparing an activity for your classroom. So in the second section, you will find a description of how you have to build the grid on the floor, and also there are ready to use and print tiles. So in appendix, you will find the 4 tiles that you can print and in A4 format that are perfectly big enough to cover the size of an actual tile. So our suggestion is to print them in color, of course, and to add a surface if you have the options in order to make them reusable, and to start coding on the floor, let's say. So that's the section in which you, as an educators, you will receive all the information on how to prepare the grid into your classroom, where to print and how to print the tiles, and also to prepare other technical and practical aspects of the classroom setting. So that's the second section. And then we're ready for the first section, which is the lesson plan somehow.
Yep. And the lesson plan is the one that describes the activity that we have just demonstrated, the pas de deux.
Exactly. And we, thanks to the input of the Italian leading teacher, we also include some instructions for how to deal with a remote collaboration on the CodyColor on a CodyColor challenge, because as it's well, let's say, instructed and coded because of the coordinate labels and the code, the pass de dos can be played also by 2 different groups of people in separate places. So imagine a class in Italy challenging with challenging another class in Poland, for example, and thanks to like a super simple chat messaging tool, like the educators can share the instruction, so the decision, as I was saying, as we did, to be honest, with Alessandro just a few minutes ago. So it's a really useful and easy to implement resource also for other Erasmus projects or twinning projects. And that's part of the rationale behind the motivation of the Italian leading teacher that wanted to keep on doing CodyColor activities also with other colleagues from other European countries.
Yeah. And so here, what you can see is just an example of a possible chat that allow 2 teams which are far apart to play together, or just to share the same playground virtually while they have them physically in their own places replicated on the floor. So what is nice is that this can be played as an unplugged activity in both classes, in both schools, even if they are far apart. But thanks to the system of coordinates, they can still play exactly as chess players do when they play remotely. Okay. And even if they play remotely, they can simulate the moves of the other player, the other team on their own board. So what is nice is to imagine two schools that are competing on pas de deux, but both schools having their grids on the floor and having kids playing and moving on the board, representing both the local team and the other team. Because once they know the move and the color on the floor, they can also place the piece representing the position of the other team. Okay, I hope this is clear enough. But then you have the CodyColorKIT that explains it much better than we are doing right now.
Yes, and then the last section of the kit is like a ready-to-use template that you can use in order to register all your CodyColorKIT activities on the UCode Week website, because we know that that's a way to share and bring value to your class activities, but also especially to inspire other educators and to keep on our mission to spread the importance of computational thinking and coding skills since early age. So that's, let's say, is a dissemination task that we know requires time, and that's why we provide a text and an image as a template. But it's a small seed that you can do in order to keep on the awareness around coding and computational thinking as the one of the main mission of UCode Week. And what's next? First of all, I will remind everybody that there is a chat. So if you have a question, please include the question in the chat. But we are almost at the end, and we would like to conclude this event with an invite. So we can go to the next slide. And so we would like to invite all of you to download the CodyColorKIT, to start explore and learn the method, and maybe to try to run a CodyColor activity with your classroom and to see and to observe what it did well, what it did wrong, which were your challenges, which were your difficulties. Just try to learn the method and try to apply into a classroom setting. Of course, any test, any activity that you do, it's worth being registered in the UCode Week map for the same reason I just mentioned. And but our invite is to learn and try the CodyColor activity by the middle of April, because we will invite you to a mentoring session with us again, in which you will have the chance to raise your questions, your doubts, to share your difficulties, to understand and to grasp from peers how they overcome the same difficulties, and to get inspired by other teachers and educator experiences. So our invite is, after today's event, to try the method, to try to understand and learn the method, and to take part in the next mentoring session, in which we will share our experiences together. And to do so, and to receive the slides and follow-up information, I remind you to sign your attendance through this QR code that will lead to the attendance form So we will reach you by email and send you all the materials and all the information as a follow-up email. And I think that's it. It was a really intense and interesting event from my side. I hope it was the same from the audience side.
Yeah, it was from my side as well, and I'm quite curious to know if I lost the match because I was,
We
yeah, you know,
still have to count it.
we still don't know who is the winner
Yeah, but
between
we have
us.
the
So
recording.
I invite the audience to double check, because if they go back in the recording of this video, they can find the match. And actually, what we could do, Veronica, is also to leave the slides as I modified it during the live session, so that when you provide the slides to the copy of the slides to the audience, they can have our match and try to see who is the winner.
Of course, of course.
Okay, so
Yes.
okay. I leave the modified version of the slides as the master that I will provide to you in order to distribute is as a PDF.
Okay, I don't see any question in the meantime, but they might arise later. So I would
Just
suggest to share this last slide with our email address. So if they have follow-up questions, they can share their question there.
Okay. Okay, thanks a lot. It was great. I thank you very much, Veronica, for playing with me. And so I hope you enjoyed, but I know that you are, yeah, I know that you enjoyed CodyColor, and actually developing this toolkit is your own idea. So thank you for involving us in this, so myself and the leading teachers in this very, very nice activity. And we had a great time also writing all together this toolkit. I enjoyed it.
Great.
Okay.
So thank you very much. Thank you for this evening event, and hope to see you in many participants to the mentoring session in April.
Bye-bye.
Thank you, Alessandro.
Enjoy.
Bye-bye. Thank you to anyone in the audience.